I want to give you an intuitive interpretation. So let's try that. We'll talk about a proof of the fundamental theorem a little bit later. It's not actually that hard, but we'll give it intuitive reason, interpretation, if you like, of the fundamental theorem. So this is going to be one which is not related to area, but rather to time and distance. So we'll consider x of t is your position at time t, and then x prime of t, which is the rate of change of x with respect to t, is going to be what we know as your speed. All right? And then what the theorem is telling us is the following. It's telling us the integral from a to b of v of t dt, so reading the relationship, is equal to x of b minus x of a. And so this is some kind of cumulative sum of your velocities. So let's interpret the right-hand side first. This is the distance traveled. And it's also what you would read on your odometer, right, from the beginning to the end of the trip. That's what you would read on your odometer. Whereas this is what you would read on your speedometer. Okay, so this is the interpretation. Now, I want to just go one step further into this interpretation to make the connection with the Riemann sums that we had yesterday, because those are very complicated to understand, and I want you to understand them viscerally on several different levels, because that's how you'll understand integration better. The first thing that I want to imagine, so we're going to do a thought experiment now, which is that you are extremely obsessive, and you're driving your car from time A to time B, place Q to place R, whatever, and you check your speedometer every second. Okay? So you've read your speedometer in the ith second, and you've read that you're going at this speed. Now, how far do you go in that second? Well, the answer is you go this speed times the time interval, which in this case we're imagining is 1 second. All right? So this is how far you went. So this is the time interval, and this is the distance traveled in second number I, in the ith second. The distance traveled in the ith second, that's the total distance you traveled. Now, what happens if you go the whole distance? Well, you travel the sum of all of these distances. So it's some massive sum where n is some ridiculous number of seconds, 3,600 seconds or something like that, whatever it is. And that's going to turn out to be very similar to what you would read on your odometer, right? Because during that second, you didn't change velocity very much. So the approximation that the speed at one time that you spotted it is very similar to the speed during the whole second. It doesn't change that much. So this is a pretty good approximation to how far you traveled. And so the sum is a very realistic approximation to the entire integral, which is denoted this way, which by the fundamental theorem is exactly how far you traveled. So this is x of b minus x of a. Exactly. The other one is approximate. Okay, again, this is called a Riemann sum.